The size of a batch is not written in stone. The size of the batch is under the control of management. Maybe by being smart about the batch size, we can try to improve the process. We could potentially increase capacity, or we can reduce the inventory level. But how do you set a good batch size? What is a good batch size? This is the topic of this session. In the previous session, we chose the batch size B based on demand. We pretty much ignored the rest of what's going on in the process. We just looked at the one machine with the setup. Now consider again the process of the apparel making. Recall the 4 steps in the process, including the cutting department, section 1, section 2, and finally the finishing. Recall that only the first step, the cutting department, actually had setups. Now let's first consider an arbitrary batch size of B equals to 5. With a B equals to 5, our capacity at cutting is, remember the formula, B divided by the setup time plus B times the processing time, which turns in this case to 5 divided by 20 plus 4 times 5, and that is 5 divided by 40, which is 0.125. Then at the next step we have 8 divided by 40. Notice there's no setup time here, and so we can just use our good old formula, number of workers divided by the processing time. So 8 by 40, that is 0.2. 5 by 30, which is 0.1666. And then 1 divided by 3, which is 0.333. So for a batch size of B equals to 5, we see that the bottleneck is going to be at the cutting machine. Right? You notice that the capacity here is at its minimum. Now that was just an arbitrary batch size of B equals 5. Let's consider another one. Say B equals to 50. Now at B equals to 50, here's what's going to change. At the cutting machine, we now have to look at 50 divided by 20 plus 4 times 50, and that is simply 50 divided by 220, which is roughly 0.227. And the other capacities have not changed because there was really no setup involved. Their capacity is independent of the batch size and remains at 0.1666 for section 2, 0.333 for the finishing department. Now look what has happened. By increasing the batch size from B equals 5 to B equals 50, we have been able to shift the bottleneck. Now the bottleneck is at section 2. Now this is interesting in the sense that by choosing the batch size we determine the bottleneck. For B equals 5, it looks like our batch size currently is too small. Why that? Because every time we shut down the machine, every time we shut down the cutting machine, we shut down the entire plant because cutting is the bottleneck. However, for B equals to 50, the batch size seems to be too big. Why is it too big? Well, we are optimizing the capacity, or we are increasing the capacity at the cutting machine, but it's really of no value. We are ultimately constrained by section 2, and so what's the point of operating in higher batches, hence higher inventory, at the cutting machine, only to notice that the constraint is then at section 2. To choose a good batch size, what you want to do is you want to balance the line. You know that you can increase capacity here by increasing the batch size, but only to a point, only to the point of the capacity of the next slowest step. So at a good batch size, the line is balanced, which means algebraically that the capacity as a function of the batch size, which in our case is B divided by 20 plus 4 times B, is exactly the same as the capacity at the next slowest step, which is 5 divided by 30. Solve this and you get 30B after you cross multiplied is equals to 100 plus 20B, and then you see that b has to be equals to 10. At b equals 10, we balance those forces of the one hand the desire to increase capacity at the cutting machine, but on the other hand not to waste capacity because there's a constraint downstream of the resource with the setup. So what is the bigger lesson here? The insight I want you to get is that if setups occur at the bottleneck machine, you have a strong incentive to increase the batch size. After all, every time that you're setting up at the bottleneck, it's like shutting down the entire plant. If, however, the setup occurs at non-bottleneck resource, then you have plentiful capacity at that resource, since the process capacity is going to be constrained by some other resource further down the line. Now, to see this in action, consider the following example. A little while ago, I went to a place in Disneyland called the Haunted Mansion. Here's how the Haunted Mansion works. Like with most Disney attractions, you have a long line of people standing outside waiting to get in. Inside the Haunted Mansion, there is an elevator that takes people down into the basement. Here's how the elevator works. The elevator has a certain number of people that are allowed in, and then independent of whether there's 1 or 50 people in the elevator, it takes roughly 2 minutes to go down in the elevator. Once you're in the basement, there is like a long line of moving chairs that take you through the dungeons, through the basement of the Haunted Mansion. There is basically a never-ending line of moving chairs that make you see quite spooky stuff. Standing in line here, and the operations professor that I am, I was wondering how many people at once should these folks at Disney let into the elevator. If they just take one person at a time, well, what's going to happen is the flow through the elevator would be rather small, in which case many of these seats down here would be empty. If, however, you're going to squeeze 50 people into the elevator at once, the result will be that the flow through the elevator is going to be big, but at the expense of inventory of waiting people in the basement. How do you set the number of people in the elevator? You want to find exactly the balance so that the flow through the elevator is equal to the flow of the chairs in the basement. This is the intuition how to set a batch size. It applies in my little spooky example here at Disneyland, but it's exactly the same insight I want you to take out of this session. Setups waste capacity. So what? If the resource, the machine we're setting up, is not the bottleneck, capacity at that step is plentiful. So wasting a little bit of capacity in return of a lower inventory level is actually a pretty good idea. If, however, the setup occurs at the bottleneck machine, setting up the machine is like stopping the entire process. For this reason, when we choose a good batch size in the process, we're looking for the sweet spot at which the capacity of the resource with the setup is just at the point of the capacity of the slowest step in the rest of the process.